Okay, so to do this, you first of all have to guess the first factor. Always the first factor, you have to guess it out. So what number can I input into this function so that it becomes a 0? All right, that is the first factor that you are looking for. So we're going to try out, start with a 1, then -1, the opposite, 2, -2, 3, -3, in that order. So you do a number and its opposite. So I'm going to start with +1. We are finding the factors of this number. So +1 cubed plus 3 +1 squared minus 16 1 times 1 plus 12 should give me a 0. All right, so 1 cubed is a 1 plus 1 squared, it's still a 1 times 3, I get a 3, minus 16 times 1 is still 16 plus 12 should give me a 0. This is 4 plus 12 will give me 16, and 16 minus 16 here will give me 0. 0, yes. Therefore 1 is a factor of the polynomial. That's why we say so. 1 is a 0 of the polynomial. Now to write it from a 0 to be a factor, it should be x minus 1 should be equal to 0. Therefore, our x can be 1. Therefore, 1 is a 0 of the polynomial. But in factor form, you have to transfer the 1 to the other side so that it can become a factor like this. Okay, so now the factor is written with our x as x minus 1 as a factor. So we need two other factors of this polynomial because the degree is a 3. So that is how you will get to know how many factors you are finding. The highest exponent, the degree is a 3, so I need 3 factors like this. Get it? Got it? Good. So now we need the two others, but we know that once we have extracted the first factor, the remaining factors is going to be a quadratic factor. So quadratic means the power is going to be a 2. The degree is now going to be a 2. The a is the coefficient of the x squared that we need, plus b, the coefficient of the x, plus a c, our constant number. This is a standard quadratic form. And when we multiply this by this, we are going to get this cubic polynomial that we have here. All right. Okay. So we need our a, we need our b, we need our c. There's an easy way to do this without using the synthetic division, or you're going to use the long division method and all of that. There's an easy way to do this, and that's what I'm going to show you in this video. We will look at the synthetic division and the long division in other videos that we're going to have. So we are here now. This is what we have now. All right, now our a and our c are very easy to find. We know that our c should be a 12. Whatever we are going to get here should multiply by what we have here to give us a 12. Okay, so I can look at my a is the coefficient of the x cubed. So the x cubed, the coefficient is a 1. If I multiply the x by the x squared, I'm going to get what? Ax cubed. And that is the only part in when I expand this bracket and multiply x times ax squared, x times bx, x times c. Actually, let us do that. It will make the work, our life easier and simple. So we're going to multiply out x times ax squared will give us ax cubed, plus b, x times bx will give us bx squared, x times c will give us cx, minus 1 times ax squared minus ax squared, minus 1 times bx minus bx, minus 1 times c is minus c. Then we can compare what we have here, these numbers, we can compare them to the original equation, yes, but cubic function that they have given to us. So we have ax cubed here. Comparing to this, it's equal to what? 1x cubed. Where is the 1 coming from? The coefficient of x. So the s cubed will cancel, meaning that our a, this number a, is equal to 1 from here, right? So we are comparing this, what we got here, to the original fraction. Not a fraction, to the original cubic polynomial. And ax cubed is the only term we have here which has s cubed. So we compare that to the only term which has an s cubed. So if ax cubed is equal to 1x cubed, which means that a is equal to 1, and our first term here is a 1. Get it? Got it? Good. Now let us compare our b. Okay, let me clean the side. We are done with this, so we don't need that again. Our b, we see that, okay, let me write this here. Our a is equal to 1. We are done. Our c first. B is a bit complicated, so leave it for now. C first. Now, in which of these we did do we see a c, not cx, just a c? It's here. There's c with no letter, it's here, negative c. So negative c should be equal to the constant 12, which means that c is equal to negative 12 when you divide both sides by negative 1. So the c is also easier to identify. It is the standalone number or letter. Constant term should be equal to the standalone number in the original one. Does that make sense? Okay, so our c is also 12. So c equals negative 12. I've written that down. Now the b, we left the b behind because that's a bit tricky, but it's not difficult. Now, where do we see, when we come to the b, you can choose this one, the 3x squared, or you can choose the one with the x or the one with the x squared. In one of them will work for you. Okay, so I'm going to choose the one with the x squared. Now, when we come down here, x squared is seen at bx squared, and s squared is also seen at where? A minus ax squared. This is where we see x squared, right? Good. So these two should give me the 3x squared. They should be the same. All right. Now we already know the value of a. So a, we got what? 1. So we substitute. So we're going to get, let me clean this one as well. We are going to get bx squared minus a is a 1, so 1x squared equals 3x squared. So I can transfer this to the right. Okay, they are like terms with this one. Or I can even start off, cancel out the x squared to make life easier. So we're going to get b minus 1 is equal to 3. And when I transfer the 3, my b is going, the b is going to be 3 plus 1, which is 4. So my b is a 4. Now I go back to replace these 3 letters into the original one that I wrote down as, remember we got the first factor x minus 1, and we're left with a x squared plus bx plus c. Now we know the value of a, so this will be x minus 1 times a is a 1, so 1x squared, b is 4 plus 4x, c is negative 12 minus c. So we have reduced this one term and a quadratic term. The next step is how you simplify the quadratic term here. Okay, I have videos on how you can simplify a quadratic now. It's very easy now. X squared plus 4x minus 12. It's very easy to solve. Let us look at that now. Okay, so we have now x minus 1, x squared plus 4x minus 12. We need to solve this part of it. Now, to solve that quadratic, it's very easy. We have x squared term here. So what I'm going to do is I factorize that out, x and x. Now I need 2 numbers here, which then when I multiply, I'll get negative 12. When I add, I'll get 4x. And the 2 numbers should be factors of the c, the 12. So I can think of 3 and 4. 3 times 4 is 12. It doesn't work out because when I subtract, I'm not going to get a 4. Obvious ones are what? 6 and 2, because 6 minus 2 will give me 4 here, and 6 times 2 will give me 12. So I'm going to, the 6 is a positive plus 6 minus 2, right? And x minus 1 is here. So these are the factors of the polynomial 1, 2, 3 factors. However, this is equal to 0. So we need to equate and find the zeros. Take the first one, x minus 1, take it equal to 0. X plus, which means our x is equal to positive 1 when you transfer the 1 to the other side. X plus 6 is equal to 0, which means x equals negative 6. When I transfer the positive 6 to the side, it's going to be negative 6. Okay. Then the last one, x minus 2 is equal to 0, which means x equals positive 2. Therefore, the zeros of x is equal to, we have negative 6, we have 1, and we have a 2. This is your answer. Got it? Good. So we use the comparing method to solve this, which is easier. For me, it's easier than using the synthetic division or the long division. We're going to look at a second video or a second method, not a second method, but a second example of using the same comparing method. So watch that video as well.